All right, welcome back. Dr. P here, and in this lecture, we are going to take a look at elimination reactions. So what is an elimination reaction? Well, we would have something like an alkyl halide, or something else with a leaving group, and then at what we call the beta carbon. This is the alpha, that's the beta. We're counting over from the leaving group. We react this with some kind of base, so I'm just going to call it B minus. So not boron minus, but just a base. And we'll go ahead and get an alkene plus our base becomes protonated plus Br minus. So for example, we can take the following alkyl halide, treat it with NaOET in ETOH. So the NaOT is our base, ETOH is simply the solvent. You want these two to match. So our base here is OET minus, which is CH3CH2O minus, or you could just abbreviate it as ET. The CH3CH2 is ET. Okay, what do we get? Well, we actually get a mix of products. Apologize for making that a little curved, but we get our major product is the trans, and as a minor product we get the cis. And we don't get that would be a very minor product. Because really there are multiple things, multiple ways that this elimination could proceed. Because we have hydrogens here and hydrogens here. So it's possible that we could pull off one of these hydrogens to make the double bond in the middle, or pull off one of these hydrogens to make the double bond at the end. Now, what determines what product we get? And the rule that we're going to use here is Zaitsev's rule. Sometimes called Zaitsev's rule, depending on how you convert the Russian into the Latin alphabet. But Zaitsev's rule states that in elimination reactions, the most stable alkene product forms. And we will often refer to that as the Zaitsev product. We'll see that there are some ways to get a less stable alkene, and we'll talk about that in a little bit. Okay, so let's just look at another example here. So let's say we had the following. let's have a methyl group there, bromine, do C, H, H, H. We have 2 hydrogens there. So depending on which hydrogen we remove, we could get our Zaitsev product, which is major. But then we'd also get as a minor product the Hoffman product. I always forget how many F's and M's there are in Hoffman, but we'll go with 2 of each for now. Now notice that removing one of these hydrogens gives Zaitsev, and removing one of these hydrogens gives Hoffman. We actually have more hydrogens to remove that could give Hoffman. However, the Zaitsev product is the more stable one. Now if we go back here, both of these are Zaitsev products, and this is the Hoffman product. And we'll look at that. The Hoffman product specifically refers to the less substituted product, if more than one product is possible. So what makes a stable alkene? Well, simply put, the more substituents there are on the alkene, the more stable it is. So we could have something like a tetrasubstituted, which will be the most stable. And that's more stable than a trisubstituted, which is more stable than a disubstituted, and these guys are about equal to each other here. Those are supposed to be a little, hold on, let me make that a little bit better. There we go. Little tildes there, equal sign, bent equal sign. Anyway, the geminal disubstituted and the trans are about the same stability. Cis is less stable. So that explains why before we got the trans as a major product and the cis as the minor product. And then that's more stable than monosubstituted, which of course is more stable than no substitution, excuse me. So more substituted means more stable. And then when you've got disubstituted, remember trans is more stable than cis. All right, so we can use this to help predict what kind of product we get. And remember, Zaitsev's rule, in elimination reactions, the most stable alkene product forms. We have ways of preventing the Zaitsev product from forming, and that depends on the nature of the base. And I think we'll talk about that in some future videos. All right, so next time we'll take a look at some of the details of the E2 elimination reaction. And until then, stay safe out there. Bye now.